everyone, we're going to sketch a curve whose parametric equations are given and show the orientation. We're going to identify the requested point, which is the leftmost point, and justify our point by analyzing the appropriate derivative. So let's get started with our graphs. We're going to start from our t belongs to the interval -2 to 3. So I'm going to write t, and I'll just write -2, -1, 0, 1, 2, and 3. And then find my x values and my y values, and then we'll try to find the leftmost point. So we're talking about the x. When you're talking about left or right, that's your x. If you're talking about your lowest or highest point, we're talking about the y. So basically when you substitute in -2 in here, we're going to get -2 squared is 4 minus 4 is 0. And then when you substitute in -2 here, I'm going to have to write some of this out. You're going to get 4 plus 4 plus 3. So that's 14. So let's go by 2's here. 2, 4, 6, 8, 10, 12, 14. So that's 14, and this is where we're at. Now, let's substitute, that was 14. Let's substitute in -1. -1 squared is 1. Minus 2 is -1. So we're at -1, and then substitute in -1 here. Let's see what that gives us. That's 1 plus 2 plus 3. So that's going to give me 6. 2, 4, 6. Which is right there. So here's how the curve is going. It's going to be curvy, and it's going through this, like that. And the orientation is this way. All right, next one. So that was what? 6. Now at 0, we're going to get 0 for x and 3 for y. So that's going to be right about there. So we're coming back around this way. All right, now at 1, we're going to get 1 plus 2 is 3 for your x. And for your y, we're going to get 1 minus 2 plus 3. That's going to be at 2. So at 1, we're at 2. Let's see, 1 and up to 2. So it's going up a bit here. All right, now at 2, we're going to get 2 squared, which is 4 plus 4. That's going to be 8. And 2 for this one's going to be 4. Minus 4. Let's see. I think I did this one wrong. Let me do real quick. 3, 2. This was 2. So this goes here. Sorry. This is going to go down a little bit right in there. All right. So now we're at 2. And 2 squared is 4 minus 4 plus 3. So at 2, we're at 3. And that's going to be right about there. So let's see, it keeps going around this way. And that was at 3. Now at 3, we're going to get 3 squared plus 6. So 3 squared is 9 plus 6 is 15. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Barely made it. All right, so this is 15. And then for your y, you're going to get 9 minus 6 plus 3. So that's going to go up to 6. So at 15, we're at 2, 4, 6, which is about there. So the graph is kind of looking like this as we graph each point. It's kind of going this way. It's a little off because I'm going by 1s on my scale here and going by 2s here. Basically because of what I'm drawing on. But anyway, so if you look at your leftmost point, that is this point right here, which is -1, 6. So let's see, -1, 6. All right, so that's what we did. We identified the requested point, and now we have to use the derivative to find it. Since this is our leftmost point, we're talking about our x. So let's do that. We seek to minimize x as a function of t. So you're computing your derivative of x with respect to t. So when you take that derivative, that's going to equal 2t plus 2. Now set this to 0. You're going to get 2t equals negative 2 and t equals negative 1. It's a critical point. So we're going to put negative 1 here, negative 2 here, and our endpoint 3 here. So looking at this, it's negative for this interval. And for negative 1 to 3, it's positive. So there's a relative minimum at t equals negative 1, where your x comma y equals negative 1 comma 6. And that's it. I'm sorry about the graph. I do want to point out we're supposed to stop here, and I shouldn't have put an arrow here. There. All right. Thank you. Have a nice day. Bye-bye.